Thomas Jefferson National Accelerator Facility is a laboratory for basic nuclear physics research operated by the U.S. Department of Energy. At Jefferson Lab, scientists can advance our understanding of matter itself by probing quarks and gluons in the atom's nucleus with beams of electrons from the superconducting accelerator. Jefferson Lab has an educational mission as well. The Jefferson Lab Science Series features scientists and engineers who are gifted in making their work not only informative but fun. The Science Series is held once a month in the Jefferson Lab Auditorium. The presentation is live, spontaneous, and unrehearsed.
Nigel was a counterpart of mine at Sandia National Laboratory in New Mexico, and I met him in that capacity, and we've known each other now probably, 10 years going on that order. Nigel's a very curious man, as most of us are in the science field. We like to know lots about lots of things. So Nigel, as a science writer, has learned about natural history. He knows a lot about nuclear physics. And being in New Mexico, where the sky is much more beautiful than it is here because of the altitude as well as the atmosphere out there, he looks up a lot more than we do around here and got very curious about the solar system and has written a wonderful book about it that he'd like to tell you about tonight. And I'd like to introduce Nigel Hay to you.
Many people have referred to me as a curious person, and I don't know how to take that sometimes, but I certainly have a lot of curiosity. And I think that the most important thing that I would like to pass on to you is the importance of curiosity, because being curious just brings life out, makes you realize what a part of life you are already, of the life of everything around you, and it gives you a lot more really richness coming back at you out of your environment. Whatever your environment is, with physically, intellectually, or biologically. First of all, I want to ask a question. It's a very important question. I want a show of hands. How many people have been to Mars? We've got one. Now, it's important. Thank you very much. Well, it's an important question because in New Mexico, we've got this place called Roswell. And Roswell is completely dedicated to extraterrestrial visitations, capturing, kidnapping, this sort of thing. And when I was in public relations at Sandia Labs, I would get questions from people who actually wanted to come and visit our collection of spacecraft, of alien spacecraft, UFOs, and the remains of UFO, passengers and pilots and so on, who were kept deep underground there. At the mysterious Sandia base. I was reading in my room here the literature, and it said that the only known science flying saucer in existence is right here in Newport News, which is, I guess it's at one of the museums. There's a picture of it. Maybe it's the Transportation Museum, I don't know. But I'm sure it's a joke, a bit of a joke. Another question, how many of you, if you had the opportunity, would like to go to Mars? That's more like it. I'll put my hand up for that too. So we have not a very large percentage, but more people, which is good. Any of you interested in, that already don't have them, who's interested in getting a job in science? Anybody? Yeah, not many. But I'm glad to see those hands going up. It's expected that in another 10 years or so that, or maybe less, that most of the scientists in the United States will be foreign born. Because we don't have that many people these days going into science, not as many as we had in the past. Whereas people in other countries, whether they're from South America or India or China, are very interested in coming to this country to work because of the great lab facilities at Jefferson Lab, many other places, and also, of course, the money is much, much better. How many? This is a serious question. How many of you? It sounds silly to me, but it really isn't. How many of you feel you could describe what the Cold War was? Gosh, hardly anyone. That's amazing. You writing this down, Dawn? Yes. Thank you. That's really, thank you very much for that. It's very illuminating to me, because I came to this country in the middle of the Cold War, which was between what was then the Soviet Union and the United States, a state of great tension. And who has ever heard about the idea of shooting down missiles with missiles? Oh, that's more than Cold War people. That's good. Okay. And finally, anyone who knows of anything that's more dangerous than nuclear weapons, as far as human inventions are concerned? Not many. You kind of believe in the danger of nuclear weapons. Well, thank you very much. We'll get down to this now. We'll get down to these puzzles. You know, who's interested in puzzles? Okay, great. Then we've got an interest in curiosity, which is what science is all about. That's why people here use these amazingly powerful electron beams, for example, and photon beams, to investigate the nucleus, so we can find out. It used to be, well, there are individual creatures walking about, and then you figure out these creatures have molecules, and molecules have little bits, and everything gets smaller and smaller and smaller. The atom has little bits. It has electrons, protons, neutrons, and now the protons, neutrons, and nuclei have little bits, quarks. We try to look at those. So it's all curiosity. And that's the excitement, really, of life, because human beings are explorers. Human beings are adventurers. And that's what we need. That it's a stimulus. It's something that really keeps us going. Whether we are exploring the solar system, whether we're exploring an atom, whether we're exploring the relationships between people, or your relationship with your boyfriend or your girlfriend, it's just exploring, adventuring, seeing how far you can go. I know that when I go to England, one of the wonderful things that I notice that some people don't appreciate is when a child of, say, a year old or 2 years old is playing around maybe with something on his tray, and he will or she will sort of repeatedly take something and push it off the tray. Or we'll repeatedly do something which we think is destructive. And actually, when you look at it another way, these tiny people are doing little experiments in physics. They're learning how their environment works, how different things interact with each other. And that's the way I think about, when these little kids do supposedly, nasty, bad, awful things, they're really finding out about their environment. Okay, I brought 2 speeches, both of which I've torn up, you'll be pleased to know. And can everybody see this? I think so. We'll just make this into a picture show, since I can see looking at you that some people may know less than me, but I'm sure that a lot of you know more than I do, so we'll make it into a picture show. The book. Why I'm here is because I wrote this book. It came out, it was beautiful. It's like a coffee table book, but very much smaller, easy to handle. And it's not just about the solar system, but about the people who explore the solar system. There's one guy who was a navigator of a spacecraft, a robot spacecraft, that went all the way out to Neptune, which is almost as far as you can get in this solar system. And he helped to pilot it remotely from Pasadena, California, those billions of miles. And there's a story of how the problems that came up as he was steering this thing through the incredibly huge solar system, and the problems he had, and how he fixed some of the problems. So his little stories in here. Arthur C. Clarke, a great novelist, has a little piece that he contributed. And Freeman Dyson, not so well known, but certainly a wonderful personality in physics, also did. So there are a lot of writings, short writings by people other than myself. So it's great pictures. Okay, I'm calling this Worlds Beyond the Matrix because they're beyond our personal ken, you know. They're way out in many ways. And we'll start with this now. Why in the world would I do it? Well, partly because I live in New Mexico, which is a strange place, you know, because one of the things that is so familiar to you, which is water and sea, rivers, oceans. We don't have that sort of stuff anymore. You know, some thousands, millions of years ago we did. And so one of the first things I wanted to do was go and see the sea. You know, I'm going to see some salt water, some real water that hasn't just been pumped out. And this is the kind of landscape that we have. I took this photograph. And I wanted to block off the print and ask everybody which of these pictures was Earth and which was New Mexico. And the answer is the picture at the top is one I took from not very far from my house, looking towards Albuquerque from the west. And this is a rather famous Twin Peaks picture in the bottom, which you can get from NASA in stereo. So the thing about, you know, you're getting that far out and you start looking at galaxies and you get these incredible images that are produced by people who work for the Hubble Space Telescope, for example, and other people at Johns Hopkins or wherever who get these images and they work on them with computer graphics. And maybe they start out with just data, you know, data points, and they come up with these fantastic images. Now this one is my favorite, string of pearls. And this is a cloud way out there in space called the Whirlpool Galaxy. And realize, if you will, that each of these little dots in here, there's so many dots they look like a cloud. But each of those many dots is a solar system. Every one of us is a solar system. And there are many of these galaxies out there. Millions, billions of them. So the infinity of space is something that really can't help but grab you. It's exciting. And it makes you realize how small you are, which is rather uncomfortable sometimes. But when you realize how small you are, then you realize you kind of open a door into a different kind of understanding about yourself, the universe, and everything that is. Got one more here. I put this up because it's rather similar to what we expect the Milky Way to be. If this were the Milky Way, we would be about it's a bit in from the edge at the 7 o'clock point there on this particular galaxy. The book was really, many years ago, I wrote a book on the outer planets, and through my work with the media, I was talking with the editor of Nature magazine, and I'd been working, updating this book on the outer planets for many years, and I said to him over margarita or 2 or 3, so I said, by the way, if you know someone who's interested in publishing a book on the outer planets, I have one ready for the press. And he said, you know, Nigel, it's funny you should say that. So we started out, and with a book on the outer planets, which is coming out, is for just people who are not scientists, but people who are curious, people who are excited by puzzles, questions. And it's beautifully illustrated, and it goes into technology, by which I mean, how do you do it? Not just what have we found and how pretty are these pictures, but how do you go about finding out these puzzles? And it does tour the sun and solar system planet by planet, which is kind of strange because after they said, well, we want to print the book, they said, well, this is great, you're doing it about the outer planets. How about doing the inner planets too? What about doing Earth and Moon and Venus? Would you mind doing that, and Mars? So I said, well, I could do that. So then I agreed, and that editor left, and a new editor came along. He said, Nigel, do you really mind including the sun? So I said, okay, we get the sun. So you got the whole solar system here in between two sets of covers. I include this photograph here. It's remarkable because it has so many planets in it. It's Jupiter, Saturn, Venus, and Mercury, all in this picture here. You can see the dots above Stonehenge in England, which is a Neolithic monument, which a lot of people think has astronomical implications. The idea of putting this in is just to remind ourselves again that wonder has been such an important part of human beings for so long. It has always been with us, and it's precious. And, and I see kids that are 1 through 5 through 6 to 7, 8, 9, 10. These kids are just enthralled with the world, whether it's their back garden or a baseball lot and the ants in the baseball lot or whatever. And after that, we need to hold on to it. It's not always easy. One of the things that I try to bring out is how human beings were able to reach out and communicate with, control and get data from these robotic ambassadors of humankind way out there in space. This photograph is actually this is not an actual lander, and when I first saw it, I thought this artist has gone just too far. When my scientist friends see this, they see a spacecraft with a human eye and a human brain and a human hand and a human ear. And this book is, people are supposed to read this book and think it, not laugh at it. But I showed it to a guy out at the Ames Research Lab, a very prominent man, and he loved it. So it stays, it's in the book. So we start out talking about telescopes. What's happened with telescopes is just amazing. You get some images from telescopes that look better than the stuff we get from the Hubble Space Telescope. What I mean earthbound telescopes. The one on the right, the one on the left is very early. The one on the right, very up to date. And as it says here, we can look for new extrasolar planets. That is, planets going around other star systems. The dots in the galaxy. And the other galaxies, and they're finding them. So it's just amazing. It's electronics, stuff we call adaptive optics, charge-coupled devices. You scientifically grounded people know what I'm talking about. Those things have made observations from Earth just incredible. Of course, with spacecraft, we can use them, and we do use them for everything, including your spacecraft that do actually go for the planets on the left. And on the right, the ones we don't hear about very often, but which are very important, ecologically important to weather forecasting, that sort of thing, are Earth observing platforms that just tend to go around the Earth. Or they can go around the sun. If they go around the sun, then they can intersect other planets. So what I'm trying to get across is don't be a planetary couch potato. Don't feel like you're stuck on this planet and that you have to just stay here, because you can project your mind out there. You can project your mind out there and look back at Earth from that spot, wherever you put yourself in your mind, look back at Earth and see what a very, very important place it is for us, naturally, what an unusual place it is, what a precious place it is, because it is a very, very highly unusual planet. There's nothing on Earth like Earth. And you're a galactic citizen, if you understand all that. We explained that in the late 18th century, Immanuel Kant, who was better known as a philosopher, there wasn't that much difference between philosophers and scientists at that time, came up with the idea that there was a sort of a cloud going around, well, that way or that way, and there's a cloud of matter in the universe which rotated, and over time, bits of the cloud coalesced into clumps of matter that then came together, accreted gravitationally, and became what we know today as planets and moons. And then, very much more recently, the University of California at San Diego produced the computer graphic on the right, which is, shows the same sort of thing as you've got on the left, but you have, again, a solar system which is in the process of formation, where you have a ring of planets just beginning to form. During those days, in the beginnings, we had huge collisions in this nebula, as this great washing machine of material and gases and dust was going around. And there were big chunks that had come up and small chunks, and there were collisions all over the place. It was a huge, huge interplanetary, three-dimensional, four-dimensional ping pong game, or better still, pinball machine, in which things were crashing into each other. So we find Venus, which is the top picture here, is instead of going this way around the sun, like all the other planets, it goes this way. Why? We think the only way is probably because of collisions that had put it out of kilter. And Uranus, which is huge, and is many, many times bigger, Uranus is, instead of going around like a top, like it should, it goes like this. And we think, again, planetary collisions in the early eons of the solar system. I want to do some comparisons now. If you look at this, you get an idea of the sun's surface here. Sun is so huge you can hardly see any curvature there. Mercury, Venus, Earth, Mars. See, Venus and Earth very much the same size. We've got, I think, the diameter of Mars is about 58% of that of Earth. Jupiter, Saturn, Uranus, Neptune, and Pluto and Charon at the very end. Very small, icy objects, which we'll get back to. These are the terrestrial planets, all familiar to us, and getting more and more familiar if you're watching the news at all. I put this in here because I was interested to see that they had actually taken a photograph of Earth from Mars, so you get an idea of how kind of foggy it looks, at least with this global surveyor image. But when you do examine it very closely, you can correlate those blurs on it with the Northern American and Southern American continents. I don't know about you, but I'm fascinated by the thing we call tectonics. Let me just talk about this for a moment. When we think about the Earth, we think about the Earth as our familiar terrain. It's kind of a bumpy surface with mountains, and in the hollows we have We have ice, or more likely water. But we don't sort of realize very often that this terra firma that we're walking around on right now, that actually it is one zone, and that the zone underneath it is very viscous. It's like very, very gluey molasses, if you will. And it's very hot. And it is heated and kept going, kept bubbling even, by nuclear reactions deep, deep within the Earth that are left over from that early nebula we were looking at. There were the beginnings of the nuclear furnace that's inside the Earth and keeping this molasses, hot molasses going. And on top of the hot molasses are the mountains and all the rest of it, which are actually sitting on plates. And these are what we call tectonic plates. So you've got a tectonic plate the size of Europe. You have a tectonic plate the size of the Indian subcontinent. They bang into each other sometimes. And that's when you get these huge volcanoes. And then sometimes they come apart from each other, and you get something like this, which is this bubbly stuff coming up in this, what they call a lava fountain. This is in Hawaii. And the above picture is the famous San Andreas Fault, made from actually several images that were combined to make that. And that is when you get subduction, a situation where one plate sort of goes under another, and you can form mountains. So you've got a plate like that, which is sort of flat, but if you get enough going around, then one will sort of go under the other like this, and you get a mountain. See? So it's I don't think we know of any, there's no other planet that we know of where that happens. I'm going to run along a bit faster here. Meteor crater. There are many, many meteors that have struck Earth. We don't know of many of them because we have things like weathering. Although we have forests that cover up the traces of them. But out in a place like the Southwest, there's no vegetation. Things have stayed more stable. So you can see the meteor crater, which is only a mile and a half wide. And this Arunga impact here is in Chad, which is in Central Africa. And the only reason we see that, and as you see it's 17 kilometers across, the only reason we see it is because we're able to shoot radar beams down into the sand of the Sahara. And the radar beams, if they're strong enough, these radio beams will shoot down, they go through the sand, they'll hit some harder stuff. And they come back, and you receive it with a radio antenna, and it has a different signal, a different shape. So you say, aha, there's something down there. And you keep mapping it, and you come across, and you end up with something the shape of a crater, which is really, if you took a picture with your camera, it would look like a lot of sand dunes. One of the things about the Earth is the atmosphere that we have, this wonderful atmosphere that we've grown up in as a species, like all the other creatures around us. And this is taken from the South Pole, shows the distribution like a Coriolis effect of clouds around the Earth that protects us from ultraviolet, all sorts of things, not least of which is meteorite impact, which because they come into the thick, relatively thick atmosphere, they burn up. It's friction. When something goes fast enough just into thin air, if it goes fast enough, you get friction so much it will just obliterate it. And what happens here again, this is an atmospheric effect. You get electrons coming in from the sun, say, that might be dangerous. They get caught in the atmosphere, not the atmosphere, but the magnetosphere, which is a magnetic field that goes from pole to pole. It sort of spreads out and then comes back at the other pole. And what happens is that the magnetosphere will capture electrons and funnel them towards the pole where they then enter the atmosphere and they cause ionization, and the ionization will be different colors, whether it's according to, I think green is oxygen, some other is violet is some other. I don't remember what it is right now. So all is important. Now this is something that's just come up a month ago or so. We've always been wondering about having a moon base, and it has. How many here know that we've already been to the moon? Does everybody know that? No. But several people actually went to the moon and walked to the moon in the 1960s under something called Project Apollo. So we know we can do it. We know what it's like up there. And now the idea is to have a moon base up there, not just to do ordinary lunar, look at lunar dirt, lunar dust and so on, but also to look at ways of using the moon as a very low gravity. It's 1/6 of the gravity. We would just sort of bunny hop over anything if we wanted. We would be we could jump 6 times as high as we could in this room. But this could be also used as a staging point for sending people to Mars, because it takes relatively very weak rockets to get off the moon because of the low gravity. So this is an artist's sketch. You could look at this. I can see it. I don't know whether you can, but there are vegetables growing here in hydroponic gardens. There are meeting rooms. There are crew quarters. There's lab space. There's an airlock here. So this is the sort of thing that people are taking a little more seriously, a bit more realistically, since there was a presidential statement last month saying this would be a good idea for the United States. I wanted to start with the Earth and Moon because, for obvious reasons, because they are our closest neighbors, because we are their citizens. Mercury is so close to the sun, you don't dare point the Hubble telescope at it. It would just burn out all the optics. So this picture is made up of, 8 or 10 different images from spacecraft and from telescopes taken over the years. And you can see that strip and a few splotches here where we still haven't mapped. NASA wants to send one this year, or did. I haven't heard anything of it recently. So I suspect it has fallen back in priority since I did that. The ESA is the European Space Agency, just a fraction the size of the National Aeronautics and Space Administration, but really quite productive in what it does. They're going to Mercury, they think, in something like 2009, which is more realistic. Venus is a wonderful planet. It's the same size as Earth, almost exactly. It has a greenhouse effect greater than anyone would possibly imagine. It is completely shrouded in carbon dioxide, and it beggared the imagination of anybody what was under those clouds until we started going with radars that were strong enough to penetrate the clouds and with spacecraft that were capable of orbiting the planet and making these images. So until we had them, these were pictures that came out in the 50s of what the people in the 50s, that is 50 years ago. That's not so long in civilization. And people were thinking, well, there are jungles there. There are oceans of water or oceans of soda water or something like that. And that's what people were publishing. And nowadays, we get stuff like this. And these are radar imaged cliffs, mountains, and they look as though there's some volcanism may have caused them, although there is no trace of any volcanism these days. That's one of the mysteries. The Venus Express, this is a European Space Agency project which they're just quite recently decided to start work on. It will be based on the Mars Express, which is successfully orbiting and getting some very nice pictures, which I'll show you shortly, from the red planet. Mars, these are nowadays is fairly old images. Show you here the Valles Marineris, which is the thing about Mars is it's 58% the diameter of Earth, and yet it has these huge characteristics to it. This canyon here is many times the size of the Grand Canyon and goes across more than half of the diameter here. And then this great volcano is larger than Everest ever hoped to be. This is Olympus Mons, that volcano. If you put two Everests, put one Everest on top of the other beside it, it would not reach the top of this volcano. It is a humongous volcano. There's no volcanic action. All these volcanoes seem to be dead, but they're there. So at some time, there's volcanism at Mars. At some time, we think there was free running water instead of frozen mud on Mars. And it is just absolutely fascinating. My dream is to be able to, go down in one of these canyons with a pick, with a little miner's pick, and somewhere find a little smudge of green, which is algae or something like that, and think, wow, there is life. There really is. I always thought there was, but now there's the proof. So, and these are kind of the benchmarks here of water. I mean, if you looked at that, what else could it be? I mean, some people think maybe it was liquid carbon dioxide or something like that, but this looks like the marks of water to me. This is a very recent, last couple of weeks picture, and these mesas here, probably, that one that's sort of triangle is probably the size of France. They're very large feature sizes here. And if you looked at these two, you can see that in this lake bed, if I can call this, at the bottom, you can see that there have been meteorite impacts there. You see those circles? And you see these circles higher up too. So since it dried up, there have been meteorite impacts, which can happen very easily on Mars because what? Hardly any atmosphere to slow down the meteorites. Just zap in and bury themselves. So we're doing the exploration with Spirit and Opportunity now of Mars, and I hope you're following that. It is exciting. And in the future, we may have, this is a science lab on Mars in the future sometime. This reminds me of New Mexico. This is the first shot we got from Spirit. So you can see that with Spirit and with Opportunity, you're looking at things very closely. And particularly looking at things like you're looking for rocks that seem to have come from water or that contain water. And if they contain water, then they may contain life, or life could have lived on that water, could have been perpetuated by it. This comes from, actually this painting was painted especially for the book. And I like a few things about this. One is that this sort of Quonset hut here is covered with Mars dirt, which is called regolith. And that is extremely important because of the danger that humans will have from radiation storms on the planet Mars. Because you'll have a lot of, the sun is always bubbling off various particles, rays, and on Earth we get saved from these by ozone and other things, but on Mars you don't have that, so you'd have to have a warning system. Boy, you'd dash for as much protection as possible, and this dirt would give you that. Also, notice the airplane. I think definitely we'll have UAVs going over and helping with exploration. In fact, now that I think of it, I don't see why we couldn't have UAVs sent there now. You know, they could be unfold after they got into orbit, and they could do reconnaissance of the Martian terrain. They could do a tremendous job. So I like that picture. This is neat. It's almost a 3D representation. Again, that was from the European Mars Express. This came in, I think, last month. So it looks like a planet, doesn't it? Jupiter. The red spot this is called the Great Red Spot. It's the most famous feature on the disk of Jupiter. It's a huge volcano. One of the great mysteries is that it's kept on for going. That great red spot has been there for centuries. Never goes away. The Galilean moons are extremely exciting because some of them are covered with oceans of ice. And under the oceans of ice, we have oceans of probably salt water. And your mind can run absolutely berserk thinking, what's in that water? You know, what's in that water? Do we have little, fish? Do we have little crabs? You know, do we have sea monsters or what? But what's under the ice of Europa, for example, the second one down there? And people are really, really, really excited about going there because the ice is very thick, so there's not much chance of getting good solar heating, solar energy to keep life going. However, there could be volcanism under there, volcanoes that, as happens on the Earth, volcanoes deep below the sea help to sustain colonies of fairly primitive, very, very primitive animals. And this is a new image here of someone's idea of a spacecraft that might go to Europa. It's quite large. It seems to have possibly has ion thrusters on it. No, more likely nuclear. But this is new. This is, to me, very exciting. To be on, so you go in there, you land, you have a heat source, you melt your way down through the ice, you start up your submarine, you turn on your lights, you start looking for the bug-eyed monsters. Great. And one of the things that's exciting here is that the ice is all cracked on Europa. And some of the cracks have these red marks on it. And scientists have looked at the spectra, the color of these red marks, and see a correlation between them as being very, very similar to that produced by life forms on Earth. So that's interesting. These are cracks in the ice of Europa. Saturn, we're getting further out now. The ring beauty, I was thinking, this is computer enhanced, of course. The colors represent again different elements, and possibly in the rings the size of the particles in the rings. This is the same planet, of course, from the Hubble telescope without any computer adjustment. This Cassini mission is supposed to arrive this July. And I was thinking today how remarkable it is that we haven't heard anything about this mission, which is supposed to arrive less than 6 months from now. And it's supposed to send down this probe right down through the atmosphere into a moon called Titan, which is very, very unusual. It has lakes made of things like acetylene, maybe, or strange lakes of hydrocarbons, we think. And why haven't they done that? And well, I suspect it's because there's so much else going on in space. They don't want to take the spotlight away from Mars. They don't want to take the spotlight away from the lunar expedition. They don't want to, I guess some of the people don't want to take the attention away from the fact that the Hubble Space Telescope is going to be allowed to die, it seems, some years earlier than expected because of the cost of servicing it. Uranus, we're getting further out. All we have is this very cloudy picture, and those are clouds. But there is this one moon here, that you look at that, and you can just see how it's being gouged by these crashes in the early formation of the solar system. I say here what could have caused them, and I don't see what else. Something has crashed into it and grazed it. What's under Uranus, under those clouds, we don't know. All we know is that really for the size of it, it's very lightweight, so it's gaseous. I really like what Karkoshka has done here. He did manage to find these. I'm trying to think of what these pink spots are. Anybody know?
They're high-altitude clouds.
What?
They're high-altitude clouds.
They're clouds, yeah. They're clouds, and I'm trying to think whether they're methane or not. And you can see on the moons, several moons, 5 moons at least here. And then here he went further, and he said which moons they were and so on. Neptune is the farthest out of the planets that we have explored. That's with the Voyager 2 spacecraft in the late 70s. It's interesting to me that the image on the top, which is from the Keck telescope on the Earth's surface, really has done such a good job of imaging Neptune. And it is not really that much inferior to the computer-enhanced image from Voyager 2 at the bottom. And again, there's Karkoshka's work, trying to get more data, more information out of, in this case, Neptune. And this is, to me, it's my favorite picture of Neptune. It's not Neptune at all, but its moon, Triton. This is, so far away, right? So practically on the edge of the solar system. And in this image, we see something that could be ice, and maybe a fringe, maybe there's down here is rock, I don't know, maybe it's all ice. But the really weird thing about it is, if I can use this pointer for the first time, the interesting thing about this image is, see this guy, and this, these three? Those are geysers. Those are Yellowstone-type geysers shooting up into the air. And what we think is that they're made not out of water, but out of hydrogen, or nitrogen rather. And these are the shadows here cast by those geysers. And they seem to go up about 5 miles up into the atmosphere of whatever there is atmosphere there. And then they're cut off almost at a right angle, as though they were sheared off by very fast winds. So I love this picture. And don't ask me what these freeways are, because I have no idea at all. They look like centipede tracks to me. Finally, we get to Pluto and Charon. There's this good-natured argument going on about, are they really planets, or are they something else? Certainly they are. They appear to be. You can see, look at all the pixels there. You can see how difficult it is to image them. These are twin planets that sort of have a common center of gravity, maybe a quarter of the way into the diameter of Pluto. And they are very closely related to the other things that are out just on the fringe, like a halo around the solar system. Who knows what this is? What's out there beyond Pluto? Yeah. Anybody else? Yeah, we've got 2 people for the Oort cloud, that's right. The Oort cloud is, and then there's, I'm thinking of the Kuiper belt. The Oort cloud is something that we think is out there. Theoretically, it almost has to be out there. It has not been found. These Kuiper belt, the Kuiper belt objects have been imaged. We have a couple of them that have been imaged quite recently. And these guys, Pluto and Charon, seem to be the Kuiper belt objects to a lot of people. And therefore, they say they can't be both planets and Kuiper belt objects. And I say, rubbish, they can. When in doubt, send out a spacecraft. One of these days we might see Pluto and Charon actually in focus. This is what Pat Rawlings thinks is probably out there. We even have an idea for a spacecraft. And then that's kind of winds up what I have to say about our solar system. Try not to get into too much depth. What the excitement that is going on, has been going on over the past 3 years in particular, about solar systems beyond our own that have planets. What planets are out there? And the telescopes are so great these days, they are so precise and so capable that you can actually see planets going around. You can actually infer planets going around other solar systems. And that is because the effect of if you've got a sun here and a planet here, the sun is going to be dragged a little bit towards the planet by gravitation. So the system seems to wobble if you look at it. The sun doesn't quite stay in the same place. And so they can actually look at the amount of wobble and decide not only whether there is a large planet there, like something many times the size of Jupiter, for example. But they can say whether there are 2 planets, there are 3 planets. But all the planets we've found so far are as much as 17 times the size of Jupiter. And Jupiter being so big that some people think it's a sun that never made it, it's a failed sun. But they are actually finding these wobbly suns that have to have 1, 2, 3 big planets or planets around it, and which then we think must have small planets that you just can't see. They're too small to cause any change in the wobble. And the small planets are where we think we're going to find life. An exciting thing that happened, was announced just this month, is the discovery of oxygen and carbon on one of these so-called extrasolar planets. And that is really amazing. You know, you find something so incredibly far away, and you're looking at an image of something as it was 150 years ago, because it's 150 light years away. And you say, aha, from this spectrum I can see that it has carbon and it has oxygen. And what has carbon and oxygen? Well, we're made of carbon, we breathe oxygen, other creatures do, and that's a very important thing to be able to do. Although in the case of this particular planet, it is so large that nothing could possibly, and so hot, nothing could survive on it. There's a lot of confidence now that we'll be able to go in with the new telescopes we have and find things, even spectra that are typical of chlorophyll. And boy, if you find that, wow, those guys are out there, you know. So that really ends my comments. I wanted just to finish by, again, saying how important and how precious it is to try to hold on to the wonderful human gift of curiosity, of wonder, of being excited by puzzles. Whether you're a scientist or not, it doesn't matter. This is part of the human condition, and it's a precious part. So that think of that kid, you know, shoving food off or spoons off his plate or whatever to see whether they bounce or what, and try and get back to that state of wonder, even if you've gone through the trials of the teens, the trials of middle age, the trials of old age or whatever. Try to hold on to wonder, because that's one of the most important things that we as human beings have to offer to ourselves and the rest of the world. So thank you very much. If there are any questions? Linda?
Thank you, Nigel. Are there any questions in the audience that Nigel can answer? If not, he'll be here afterwards and would be happy to answer questions.
And we have books. We have a few books for sale. Thank you very much. Thank you.
With the Hubble telescope, you said they were thinking about just letting it die?
Yeah, they're expecting to retire it in 2010 anyway, but they're going to stop the plan now. They're, you know,